All right, now let's look at A max in terms of F and A. So in order to look at A max, let's use dynamics, because we know from Newton's second law the net force acting on some object will equal its mass times acceleration. So when this is at its greatest, the net force must be at its greatest. So if we look at an oscillating system, let's just redraw a horizontal oscillator where this is equilibrium. As you stretch it outward, the spring force, so here the net force is 0. Here it's compressed, and then it's going to have a force pushing back towards equilibrium. And then here, as it's stretched, it's going to have a force pushing back towards equilibrium. But that force, the net force, which is provided by the spring force, will be max, or maximum, at max stretch. Because we know that from Hooke's law, spring force is equal to minus k times the stretch, delta x or x. So the more delta x I stretch it, the greater the spring force. And remember, the negative is, if this is a positive delta x, this is a negative for spring. Spring pulls back towards equilibrium. So I want to come up with an expression at the max stretch for the acceleration. So I know that my spring force is minus k times delta x. So let's take Newton's second law. Now, the maximum acceleration occurs when Fsp is at its max, so that becomes negative k times delta x, where in this case delta x is a, right? Minus ka equals m times a. Now, this negative sign comes from the fact that the force is opposite the direction of the displacement. But if my force is to the left, and I'm calling this negative with a positive displacement, that means my acceleration is also negative. So these two values, the magnitude of the force and the magnitude of the acceleration, will be in the same direction. They will be in agreement with one another. So I can say A equals k over m times the maximum amplitude. And this is A max. Sorry, throughout all this, this is A max. Okay, well, this is one way we see A max described, but I want it in terms of the frequency and the amplitude. Or, I'm sorry, yeah, frequency and amplitude. So here we're going to pull a similar trick as we did over here, based on this same idea that 2 pi times the frequency equals square root of k over m, which is what I stole from up here. Now, notice I don't have square root of k over m. I have just k over m. So I'm going to square this whole thing. So I get 2 pi times the frequency squared, and I'm going to write it as that for now, equals k over m. And now I can use this as a substitution. So my maximum acceleration in terms of frequency in A can be found by taking 2 pi times the frequency, squaring it, and then multiplying by A. And again, these both work for horizontal or vertical mass spring oscillators. And that's how we can find Vmax or A max if we know the frequency and the amplitude. Or if we know K and M, that's how we can solve it that way using the period equation as a substitution.